successor of 10155. I can propose you that we have the updates of the 3 research networks, national research networks, and then we keep the questions for the panel. Or if there is a particular question on a presentation, you can raise it. But I think it's better to keep the question for the panel, so it will be more interactive. I will ask each speaker to introduce himself. So I'm going to give the floor first to Stanislaw Starzak. So please, Stanislaw.
Good morning. Thank you very much for choosing me against the sun. I will try to pay off that for you, so I'm trying to do it, to make my presentation fast. First of all, I apologize all of you that have already seen some of these slides, but I promise, please stay with us. I'm going to show some new also. Some people asked me to say a little bit about what we are going on, so that's why I'm also trying to address this issue. Maybe I also should say that some part of this presentation is now not necessary because Bill already said so many things I would like to share with you, but still I think that we are going to have some 15 minutes of the good presentation, I hope. That's the schedule I want to go on, so let's start as soon as possible. First of all, and very short, but to make it brief, we are now already completed our old 7-year plan, and to say so, I must mention that we have already 5 high-performance computing centers situated, let's say, in balanced way all over Poland, which were, of course, at the beginning supercomputing centers. Now they are mainly high-performance computing center, to say not of 3 of them. 22 academic networks. The typical, very characteristic thing is what I already said at the meeting before, is that these academic centers own their own fibers in cities. These are something like 600 kilometers to be covered. We own these fibers for the last couple of years. We still develop them, but in not a very enhanced way. We hope to do this in the next couple of years. The technologies, as it was popular, let's say, a few years ago, slowly we are going to the new world of optics. Country-wide network is just a traditional one. It's based on SDH. We hire this SDH link between from the national power distribution system. The total length of this link is something like 2,000 kilometers, so it's not much. But on the other hand, Poland is the country of the diameter of nearly 1,000 kilometers. A lot of different, some of the different special services being given to our customers. Some of them like VPN MBS in collaboration with European 1015 network. We are still facing problems with international connectivity. We buy bandwidth from DANTE, but it's always like this, that if we increase the bandwidth to US, for example, this is always an ideal step function. Vincent can confirm that, I guess. Of course, there is a need that community really expresses, so we must solve these problems. And we have to, at first glance, starting and facing the new challenges, we must realize our limits. Of course, what is the main limiting factor is just the lack of infrastructure in Poland. I don't want to explain why it was so, but still there is an important issue. The next issue is that expensive national transformations does not make many chances to research to make something more enhanced. We try to change the disadvantages into advantages. So we know that many of telecoms need to build new infrastructure just to cover the country with this optics and so on. And there is also a good political atmosphere to do that. We have spied a lot from many of worldwide networks. I've already said that we have seen a lot of things. So we also addressed some important trends that we wanted to inherit into our program. So the main factor that we consider in terms of hardware is that we see that optical networks are going to be much faster than computers. So what we're going to see the problem of management of terabyte data buffers, the problem of optical end-user interfaces if you want to take an advantage of all the lambdas, wavelengths issue and so on. And important also is some optical oriented protocol. I mean, Bill has already said a lot of things about that. According to services, we really believe that services will shift into the direction of taking advantage of single lambdas. That's something that we really believe in, and we will try to change it into the assumption. Of course, many things we are going to say they are advanced. This time we say advanced means broadband, quality of service supported, secure, and so on. Our assumptions according to our new plan is just scaled here. So starting from the very top, I mean from services, having middleware in between, we treat them as grids, and down to WDM wavelengths that we believe are going to be cheaper and cheaper. This is something that we want to go. I would say this. These are main tables that we put in front of our new program. Optics, grid, portals, this is something that I've already mentioned. New IT infrastructure have to serve to the whole community. This is an important issue. Country like Poland that is faced with many changes cannot spend different money for same services like, for example, in administration, in science, healthcare, and so on. So this is something that we must take into account. And cooperation with industry, which this is a real must, otherwise we cannot do anything clever. Our strategic goals, they are mentioned in terms that we see to be important, of course. New multi-band optical network, as we want to say. We want, and we are faced with the idea that within a couple of years, we don't know how much, we are going to change our economy also in terms of IT infrastructure. So to join European community, we must do a lot. So, main idea, just to define our new 5-year program. It's a Polish optical internet program. It's based on multi-band optical network plus next generation networking IT infrastructure with focus on application middleware. We have already set up this program, and the duration is as you see. There are strategic tasks already defined, starting from application level, middleware, and so on. The application-oriented infrastructure is just a very advanced labs, like telescopes, like remote-controlled labs, and so on, to collect data, to remotely control real-time applications, and so on. Of course, we see on worldwide collaboration. These are some models that we normally use. You saw them already, so I don't want to put too much stress on that. This is something that we use normally to show how we see this idea. Portals will serve services, will give services. Services will take advantage of integrated services on middleware and grids, and then we have servers, HPCs, and intelligent optical network on the bottom. There are plenty of network application. I know that I have only 15 minutes time, so I will try to skip it. You know it already. Many of people who made the presentation already mentioned that these are these application, and this what is mentioned there is some that we consider to be important for next couple of years. The idea of the optical network is as follows. We want to stage our program for building optical links into stages. First of all, we want to connect, starting this year, let's say after summer or even before summer, to connect main academic communities. This is going to be something like 2 up to 3,000 kilometers. This is still possible. I will explain it later. And then we are going to upgrade this up to 5,000 kilometers within the next 3 years. Specialized infrastructure, you can imagine what is it. The Pioneer program timetable. Last year we submitted this proposal, the idea of the program, to the Ministry of Science. Then there was a country-wide dispute, more than half a year, and after that Ministry made an approval, they allocated money, resources, and the program was officially started at the beginning of this year. Some applications, some submission rules have been already defined. Start of project was at the beginning of this year, and now we are in the phase of setting up applications for projects, and we are in the phase of negotiation with operators to make a joint investment in fiber optics. There is also a test bed. We started this test bed trying to test optical technologies. Last year, you probably saw our test bed. It was wide area test bed. Altogether, considering WDM and very heterogeneous staff of many operators, I want to mention them now. Altogether it was something like that, so we had, I think, 670 kilometers of our test bed, different technologies being used, and trying to see if existing infrastructure in terms of boxes can cooperate at the very beginning with the optical backbone. Some applications have been demonstrated. You can pick up from pictures what was that. Computational wind. Bill already mentioned the idea of LGI grid. We tried that. It's working. Maybe we do not have such a big amount of LGIs, but still it's running. It's trying to balance traffic over the RSF facility. Some additional distributed data archiving. Some of them are still doing so, some not. Then we extended this test bed using something about 100 kilometer gigabit Ethernet link between 2 cities. This is still an ongoing project. We want to do it better. What's going on now? I will try to answer the question of Sabine, to make comments on update, and this is the real story. A test bed, an infrastructure development, video international collaboration. First of all, in a test bed, we are trying now to infer what other people are doing. We moved to the multi-vendor heterogeneous environment even more, interoperability, quantitative test made. This is something that we wanted to do together with DANTE, using task forces and trying to get in touch with the rest of the community. The demonstration was made at our national conference April 2001. There was a similar idea of quality of service IP premium. This was already reported as a technical program by Meyer. Probably he is going to tell a little bit more about it, so I will not cover that. Just only the idea that we tried to test. It was not yet very much, it was rather quantitative study than technical measurement, I would say, but we are slowly going to that direction, especially that we still wait for some more boxes to come. What we set up? We set up already quality of service world. You can see vendors are already mentioned, using the ATM operation network. At the top we set up some kind of workstation that the traffic has been controlled by software routers using Linux and FreeBSD, Linux, and then we had some infrastructure that made us to enable us to inject some noise traffic to see how this quality of service is preserved according to changes of links, and trying to put this traffic between different boxes using Cisco, using Alcatel, using Ericsson, and so on. This is the way we try to get in touch with people in task forces. Another part of the testbed was just MPLS world. We call it that way. Just setting up two different paths over WDM. We tried to see what is the reaction of this staff according to the lack of connectivity and fiber optic, trying to see if different boxes coming from different vendors can collaborate over the MPLS world. If you are interested in more details, there are some colleagues who are busy with this experiment. They will explain much more and much better than I can do. About the infrastructure, offers from the operators have been already obtained. We started this at the beginning of this year. Now we are doing some evaluation and selection of these offers. The important issue that we saw in the right-of-way, I already mentioned that. There are many vendors and there are many operators, and they propose different solutions. They go along roads, they go along railways, power lines, and they go over even traditional way. The issue is that each kind of stuff costs differently. So this is an important point. Of course, different operators have different telehousing, and so this is also to be considered if we see the total cost of the investment. The right-of-way can be covered in a different way. You can pay at the beginning, at a glance, but you also can pay that for many years. The financial model could be different. This is the problem of ownership. Some operators say, okay, we can do this together. You pay your bill, we pay our bill, proportionally to the amount of fibers we own. Some say, no, this is not what we are interested in. We are going to do our investment ourselves. Whatever you do, if you want to join us, please, we can hire you. Fibers for some amount of years. We are going to cover also the cost of maintenance and so on. What is really necessary is just a close collaboration during the time of fibers being exploited. We see that at the moment we can spend something, this year we can spend something like 10 million euros for this investment. So considering different, let's say, offers, we see that this is going to be enough for something like 1,000 up to 3,000 kilometers. Some operators already do their investment, so what we have to do is just to adapt some technical plans to some technical projects to our requirements according to the distance and so on. They are mostly interested in putting fibers that can run traffic up to 2.5 gigabit, because they are mainly telecommunication operators. We are of course interested in much more, wanting also to have to be able to put some additional noise dispersion fibers and so on. This is a tough issue. Sometimes we have offers that say, okay, if we are going to build something, we can do additional pipes, and then you can hire these pipes, or you can pay for your pipes, then you can put fibers at the moment that you are ready to pay more for these special fibers. Of course, there's a question if somebody can do these amounts of kilometers of fibers in a couple of months. This is also a question of trust to investors. And but still we expect negotiations to be completed in June. Some decision at the government level also are expected at the end of this week. So I would feel much more comfortable if the presentation is going to be, let's say, Saturday probably. But still, I'm pretty sure that we are going to start these issues. What's the main issue from the point of view of doing this kind of investment? In my opinion, my personal opinion, is that the security of investment. We are the public sector, they are the private sector. They are afraid that we cannot receive money next couple of years, for example. But we are also afraid that they could fail and just disappear from the market also within a couple of years. So this is a very tough issue. Ownership model, I already said about that. Optical transmission system selection is just scheduled for the next half of year. We are not busy with that now, so please don't ask me what we want to do. How many time I have already? I'm nearly over, yeah? Okay, so I'm going to speed up. According to application, we have a model that to include business, we must do some consortia, university and business. There was nothing like that until now. We are allowed to do that, but the model is not well developed. So this is something that we have to be very much to work much on that issue. Well, you can read easily what we are now doing in that area, international collaboration. I put on the first bullet a participation in Torino, not because this is a conference of Torino, but because I'm more or less responsible for that collaboration, and I feel that this was a very hard takeoff for us. Not so much people from Poland are still participating in task forces. We try to increase that. We must, I don't want to say we should, but we must do much better. We of course participate in GÉANT project as most of us. There is an idea of so-called e-region. I don't want to make any reasoning because time is nearly over. What I wanted to say is that there are some requirements from local communities collaborating over the border. We all have important problems with the Oder River, so we want to collaborate between universities and between communities how to address that. And there are some also traditional links between universities, so we think about the small project that will bring us much more collaboration. We also think about how to make Torino be a part of that. Some activities according to the supplying proposals to EC are already online, are already on those way. So maybe we can say it more clearly. I'm going to conclusions. First of all, I think the Pioneer seem to take off. Long-term weather forecast, that's a difficult issue. We are faced nearly within a couple of months with the election, so that can bring some maybe slight changes. Fiber optics are really available on acceptable basis, even in not rich countries. This is what I wanted to say. I forgot to say this at the meeting at the presentation of Canary. Why? Because somebody can say Canada is a rich country, so they can do everything. But what I wanted to point out just now, this is very true when saying this is not expensive business. Of course, you must do a lot of effort. This is not the case that you put money on the table and say, hey guys, give me for this money something that you can sell me. You have to invest a lot, but still, I mean in terms of effort, but still it's cheap. According to offers that we now have for, let's say, even Lambda hiring, the return of investment is expected within the 3 or 5 years. new financial and ownership model has to be necessarily developed. And of course, all other things. Last slide. I want to bring you to my crazy idea, the importance of the European joint vision. Not because I'm a crazy guy, but because I'm coming from the country that really needs collaboration, and the countries like Poland really needs to do something together. If we want to make a pressure on our government, we must say, okay, Europe is going to some direction. Please keep in touch, because we can lose what we have already done. So I'm still trying to explain this is important, not only for us, I mean for Europe also. If you have some ambitious plans like we have been described yesterday, it's an important issue. So my mission is just to say, let's dream together how we want the European academic networking to look like in 2010. Sometimes, it's important to say, I have a dream, and things changing. Thank you very much for your attention.
Thank you, Stanislaw. So let's meet again in 10 years. Let me see. 9 years.
9 years. It's not so far. It's not so far.
Okay. I think so. Demetrius, yes.
So I'd like to welcome you all to this presentation. It is about GÉANT 2 or GÉANT 2001, and this is the effort in order to design the new optical internet of Greece. This is a case study that was made from a team, and I was a member of this team, and there was a lot of others from universities and from GÉANT. So my structure of this presentation is the following. I'm going to have a very short view on the current status, and then we're going to have a view on the basic design principles for GÉANT 2, and I think much of them can be applied to a lot of other infrastructures, and some implementation considerations of this two-layer architecture, and then details about the implementation plan. So the current status is that our network is fairly homogeneous. That means that it's much the same like in the other countries, which is a bunch of Cisco routers and some ATM switches, which are privately owned. So we are running our own ATM service, and the service is IP over ATM over SDH. That means we have all the overhead of the SDH layers, and we pretty much found that we are faced by technological limits. That means that we can't go much more than 2.5 gigabits, and that's because of limited SAR capabilities, which is the segmentation recently of ATM engines. The network offered no QoS in the IP layer. Of course, we had the possibility to offer QoS, but by means of ATM capabilities and CBR and this kind of stuff. So that gave us some insufficient capacity allocation and bandwidth management mechanism. That means that you have to apply in specific forms in order to get a reservation for capacity between 2 points, and that was much like what the P&Os think about customer provisioning and service provisioning. And of course, we had no IP VPNs. VPNs could only be implemented by means of ATM. And although we had full ATM technology, that means we had signaling and PNI and this kind of stuff, and it took us about 3 months to set it up. Nobody wanted it, so it was about disgrace to the ATM, at least. So our main principle for the new network was that we need an optical transmission because of the distances, and we could either go with a fiber lease or lambda provisioning. That means either we can find an incumbent operator who can rent some fiber, or he can provide some lambda. We would like to have this kind of lambda provisioning through a management system in order to achieve what Bill said before, to have a way to route our own lambdas in the specific points. And then we said we'd like to have a minimization of overlay technologies. We knew that having to do with a lot of overlay technologies could add a lot of management efforts on the total layer, so that could be not so beneficial in the service that we were receiving from the P&Os. And at last we considered a lot of link layer protocols, and among them are POS, with our segment layers, GÉANT and SRP. SRP is now the evolution of DPT from Cisco. Is a spatially reduced protocol and is now being in the standard track for IEEE. It's called Pullman's ring. So our main principle is that we want to have a two-layer architecture, and we decided that because we had a very exciting, very deep overview of the existing high-speed NRM network upgrades. Kind 3, I believe, had a two-layer architecture. That means that they have a backbone architecture and an access network. And the backbone capacity was sometimes not the total amount of access capacity, but it was a rate. And this kind of rate was hard to get. It was hard to implement what is the amount that we have to always subscribe the network in the backbone in order to have a very good network. So we knew before that with the ATM technology and the IP routing, we had a suboptimal path selection with existing network routing protocols. That means that we knew that the majority of our traffic goes to internet connectivity. That means that this point of our network is a kind of a drain. That means everything goes there, and we can't. It's difficult. Let's say that difficult to make traffic engineering in a dynamic way. That means that we have to do that by building PVCs or VPs with the ATM stuff, and that is another management layer that we had to get rid of. So we'd like to have some IP traffic engineering, and some candidates could be the native MPLS of the routing architecture, but we are not very strict to that. I mean, if there are tools that we can manage to have traffic engineering, we can employ them. So another aspect was that there are no clear results based on the aggregation of access traffic characteristics. That means that how much do you dimension your network when you have 5 access ports of OC48? It's not true that you have to do with a higher scale or with the sum of that. So there are two potential solutions on that, and one is over provisioning. That means you fail as much as you can, and the other is QS. Since we are, Mediterranean country and we don't have this kind of superfluous amount of capacity, we decided that we can go for QS for some years, and then we can switch over to over provisioning when the price of bandwidth gets lower and lower. So we said that we came along with QS but on layer 3, that means on IP only. And we decided that we would like to do classification and policing on the IP layer. And well, we reviewed some queuing that we need to employ in order to have QS from different vendors, either WFQ, weighted red, weighted on-ready red, and WRED for building the QS mechanism, at least on the specific boxes. So, but the major issue is what is the service we are going to deliver, and there is a very big consider on this, because we think virtual wire, although it's a very good documented, it has a very good and very clear service provisioning model for the end customers. That means that we might end up again to a service which is very difficult to deploy for the end customers. You have to do false completion and in order to provide this service, although it eliminates one layer of management. We think of providing at the beginning a minimum guarantee of bandwidth with some prediction on the packet loss. So we are not focusing on jitter constraints. And the main reason for that is it's easy for someone who has predefined packet loss and round trip delay to estimate his overall throughput. So we think that this could be something better than best effort, and we're not yet looking at virtual wire, but we're not sure about that yet. So how are we going to deploy the extra service, which is the minimum capacity? We think that the only possible way to do that in a scalable way is to deploy some regulatory infrastructure. That is a directory server where every university will has its own bandwidth capacity allocation defined there. So they're going to have a bag of tokens of bandwidth, and they will use that according to what they have applied that, or for in a period of 3 months or 1 day or whatever. So we'd like to have the regulatory infrastructure, and we're now in the process of defining the mechanism for access regulations. That means that either through some kind of middleware through the ALDA protocol, or having a mechanism where you can map these regulatory actions on the physical layer. A lot of FM switches are enabled with COPS or DANTE capabilities, so it's possible that you can do that. Another issue in GÉANT is the internet connectivity. We face very congestion every 6 months, and of course the easy solution to that is to upgrade the international connectivity, but in our case I think this is a very bad solution, because dimensioning of our network is being done with regard to international connectivity. So this is a kind of chicken egg problem. Every time we upgrade that, we have to redesign the network, the access capacities of all the customers, and then we have to go again and upgrade the capacity. So we'd like to have a bandwidth management mechanism to customers according to the predefined policy, so that everyone knows that for 1 month they have some kind of very good bandwidth profile to US, and some of it could be best effort. But we'd like this to be predefined. There are some really advanced services that we'd like to see them implemented. IPv6 is something which is really pushed from EU, but we don't see really a lot of vendors implementing that. And maybe we are going to provide the VPN service on Lambda. That's because of the grid that we might want that, and we'd like to cooperate with our Pioneer project in order to see how we can make VPN on Lambdas be transparent to the infrastructure. It depends heavily on the management infrastructure of the PMOs. As I said before, provisioning and management of the bandwidth of minimum guaranteed bandwidth between the access point is a kind of advanced service, and we don't think we can have from day zero this kind of service readily available. Another service is a large-scale conference, which really is an issue in GÉANT because we'd like to have big conference because it diminishes the cost of traveling from Greece to Europe, mainly Central Europe. So with the gigabits, we figure out that we need gigabits. Gigabits are distributed switching and routing infrastructure. We picked up POS encapsulation for one and UD for the man. The main reason for picking a POS was because the PMO couldn't provide us the places where we can install our regeneration facility. So we had to go by them. So we had to use only POS. And then in MAN we used Gigabit Ethernet because of its reduced cost. And we have 3 gigabits. You have gigabits in 3 cities, and the speeds are multiples of OC48. Generally, the customer edge infrastructure is a gigabit Ethernet switch for providing access. The one layout is what's being displayed here. So we have 3 cities which have the same access capacity, which is a multiple of 2.5 gigabit per second, and we have some other cities which are again connected to either to Athens or to Thessaloniki. So the pop layout, which is like what you said before, every road cycle, is something like that. So you see there's a switch for terminating the access connections, the physical access connections, and then there's a gigabit router. There you can see an ATM switch. So this for having the old circuits from 10155 or the connections from universities which had in the previous phase ATM connections to connect it in the new gigabit. What's the really good point of that solution is that the customer has very efficient and inexpensive solution that he needs only Gigabit Ethernet connection and Gigabit Ethernet card to his router, so he can connect very easily whenever he likes. In this diagram, we display what is the administrative domains between the customers and the PMO. So you see some of the infrastructure is owned by the PMO, some other from customer, and some other from GÉANT. And this is very essential because in every network it is essential that management domains not get mixed into each other, and has to be very clear definition where one starts and when the other begins ends. So the main characteristics are mainly this ring topology. The access is a Gigabit Ethernet, and the protection could be either, in a very simple sense, in a modified spanning tree. We know that modified spanning trees for having protection in a sub-second failover, and this could provide very easily VPN services based on VLAN technologies. So here you see again that's the MAN access and the customer. You see you have MPLS router because you might need to do some traffic engineering. You might want to connect this customer to a neighboring router, so you might end up going somewhere else. So you have the GÉANT access switch and the customer switch, and this is where the all things happen. this is the topology that we picked up and was engineered with PMO engineers. We found where are the best places to install the WDM infrastructure and how we can segment the ring in order to have two smaller rings with a distance less than 10 kilometers for the customer in order to use a very cheap infrastructure. That means either LX interfaces on single mode or multi-mode fiber links. And based on the previous diagram, you see how the layer 3 infrastructure and layer 2 infrastructure gets connected to the topology. And this is mainly the physical layer, I mean WDM and ADM infrastructure and layer 3 infrastructure and the management domains between them. I don't think this is of interest to you, but we came up with specifications about the fibers and the testing tools and restoration techniques and kilometers distance between the access nodes and the aggregation nodes. So this could be very beneficial to your case, I mean, if you are going to upgrade to an optical network. So we set up further requirements and for spare lambdas for testing multiple frames, if it's possible, in a single wavelength, optical switching conversion, and digital wrapper techniques in order to do a lot of things. I'm skipping over. Maybe two, three more things that are very important. You have to take into consideration the optical stuff in regard to the gigabit, to the lambda separation. I mean, what is necessary specifications in order to connect two optical devices. So it's very important. And these are other specifications with regard to optical channel header protection. Something about the implementation plan. The study phase ended by the second quarter of 2001, and the infrastructure RFP will be ready by third quarter, and lambda provision will start by fourth quarter. Although the one part of that is already ready, we're waiting for the man, and the cost of that is about 3 million euros, and we have 75% funding from the EU and 25% by national resources. I'd like to thank you all of you for this.
Thank you. I think the materials will be available for questions during lunch or other days. So next speaker is Mauro Campanella. He's kindly replacing Enzo Valente, who could not make it today. So after Mauro's presentation, I think he will open the floor for some technical discussions, and then we will switch to Vincent.
Well, first, the good news, I have only 4 slides. Then the bad news, Italy is an old country. Apart from historical reasons, an old country means to me that networking in Italy has been up since 20 years, 25 years. That means that we have a lot of rules, a lot of regulations, a lot of things that actually does not allow us to be as free as in Poland or in Greece. So, this is the current infrastructure. Being an old infrastructure, is mainly based on Lizard line, HDLC line, and there is ATM, because 5 or 10 years ago that was the only thing that can go higher than 4 megabit. So the current infrastructure is, as you know, they just started to put some optical layer in the network itself, but the network by itself, and the only provider up to 4 years ago, which was Telecom Italia, is a very old provider, both from the person point of view and both from the technical point. So they are very good at making phone networks, but not data networks. So what's going to happen? Well, in any case, we are trying to do what they already shown. I was hoping that they will talk about we need gigabit, we will need lambda, so thanks for believing me for that. We are setting up this infrastructure. By the way, this is the same infrastructure that we had that we had opened to the combined Tirrenia-DANTE task force for advanced testing. This test bed, together with the France test bed, is available for GÉANT and interconnect test. In particular for IP premium, and more people are taking part to the GÉANT development and GÉANT. Could you hear me? Yes. Maybe it's better. Not too much. This is up and running since 2 days. The point is that I will talk to you about why we had some problems. Essentially, it is a triangle, 2.5 gigabit on lambda. The interface is SDH. The distances between the points is, this is written in one-way delay, but is about 600 kilometers the longest path, and 300 and 300 the other ones. That means there is a reasonable way to look at the things. And the other point is that it is not a single fiber. Between going from Milan to Rome, we go through optical switches, Marconi equipment, and we go through optical repeaters. In my opinion, this is important because one of the points we have to keep in mind, and this is one of the things that we have seen in this network, is that there is a lot of bit error rate in the beginning, just because of dust, just because they make the wrong connection with the SC connector, which is loose, and so on. So having a path which is not a single fiber actually tells you a lot about the reality of implementing lambdas. The switching and routing equipment is a loan from the various vendors. There are 12,000, unfortunately not 12,400, and Juniper and 20, and the strange round things is a Riverstone switch. The Riverstone switch is a switch which is the class of the 6000, Cisco 6000, and the reason is there is that when you think at advanced services, then you probably want to decouple the classification, policing, and things like that from the pure core switching. So what I wanted to do with this kind of thing is to try to see a two-box model works, or just doing everything is on one box works. This is why we have 3 objects. Okay, so we are doing this one, and we hope to add an additional triangle by an additional service provider, so that we can see the different provisioning of lambda between different providers, and we can also have a more meshed network, which is even more important. So, the model is to go to something like that in the nearest future. Nearest future means before the end of this year, if possible. That means that we would not have SDHs as transport, but we will transport over lambdas. And we will still keep, of course, some ATM parts and some SDH interface. The next step, timescale is not very clear, because we have to replace equipment in users premise too, is to get rid of ATM. I'm very happy about that. And still keep probably the SDH interface. The last step, don't know when, is to directly connect the routers to the optical equipment. There is a very active IP optical IETF group, but I think it's not real soon now. It will be in 2 years or 3 years time scale. Well, I think that the reason has been quietly well addressed by the previous speakers, which are the key elements of the GÉANT network. We want to have gigapops. We are talking about gigapops in neutral premise. I don't want to have to deal with ISPs or telecoms. I want to have gigapops as accessible as possible, as easy to reach, as easy to modify as possible. The research network should be a focal point for the community, in my opinion. That means that we are trying to set gigapops as central interchange point for MANs and regional networks too. And the access bandwidth for both regional MANs and MANs should be the highest possible. The reason for that is that one of the key points for the research network is to export information, to export education. That means that from the rest of the country, the access to our network should be the highest possible. This is the idea behind it. And if you take into account that in addition to that, there is, in my opinion, there is still even more true that we are 80% towards US and Europe from our country and only 20% inside our country. That's not a major issue. You can put a gigabit internet to your local area LAN and it won't be loaded. We want to have what I call a unitary model. Unitary model means GÉANT should be still the network of the whole research institute, and everyone should be part of GÉANT. If a research institute or a university decides to use another ISP, that's not GÉANT. It's not a research network. And we don't want to build the research network out of 5 different ISPs and combine them together. We want to have to simplify a star model, okay? The state co-financing will be at 50%. We just have had elections, so I don't know. I hope so, at least so. We want to give access to the student populations, exactly for the reasons I told you before. We should export and let people access information as much as possible. Of course, we want to have a full integration to Europe, in particular for test activities. That's a crucial point. That is why we are setting up those test beds. Well, Italy, the graph of Italy is there, but I think everyone knows, has a very nice position, in my opinion, because it is exactly in the middle of the Mediterranean country. That means that fibers could, in principle, be led very easily from Italy to not only to Europe but also to Africa. Telecom Italia never did that. Think of the profound impact of the lack of one cable from Italy to a nearby African country for Europe. It's a very small amount of money compared to everything you can think of. But it may really cross a lot of borders, and this is what we're talking about. So I hope that our European government, I'm not saying Italian, European government will think about that. And that is true also for other countries. It's the cross-border thing that you just mentioned before. I want to be data link agnostic. GÉANT should not be engineered according to a particular data link. That will always bring problems. So I want to have a layer-free model, a reasonable layer-free model. I want to have the freedom to change the data link. Well, what are the problems? The problems is that, okay, we are talking about high-speed links in the core. That's fine. It's easy. Actually, the Milan-Rome link went up very easily. Well, with some hiccups and such, but it took 1 week. But then, if I think of the University of Milan, which is a very high-level university with reasonable financing, then they still have a lot of 10 megabit shared internet there. So, there are two things. One is that inside Italy, the regions are not equal. The north is more advanced than south for many reasons. And larger cities usually are much more appealing to ISPs than countries. So if you live in a city, or if your university is in a city, then it can be that the fiber is just laying it down. By the way, we do not have any dark fiber now because we are not allowed to. We can't. Maybe we could have something. This is being old, you know. So LAN, as I told you before, is another point. The investment now in Lambda is minimum, but the investment to renew lands in an old university is a very large amount of money. And that has to be taken into account if we want to export high quality, new services to those universities. The other problem is that what I see usually is that there is a lack of culture in the university in the good sense, in the sense that for the newer technologies, often people misconfigure things. The configuration of a Cisco router, if you want to enable something which is not trivial, is not trivial at all. DWDM infrastructure is new. That means that if you really want to build a complex DWDM infrastructure, I expect problems. It's normal, but that means that your time scale will be 3 months, 4 months longer than you expected, just because of the loose cable, just because of they do not know how to switch lambdas and so on. And another fact that I think we have to deal is that we will use multiple service providers probably, because of the tenders, because of other things. And this is new too. We do not have only one party, we will have 2 or 3 parties that we have to make them speak together. This is a nightmare, according to my experience, but we will have to deal with that. That's all. Thanks.
Thank you, Mauro. You did a good job in your last slides because it was a good conclusion to launch the short discussion we can have now. So, are there some questions from the audience? I hope so. No. Yes. David, please. Could you please give a mic?
Okay, well, we can't have no questions. I think it says Howard's going to be here, but I guess it's not Howard. But my question is, can somebody explain to me, does GÉANT have any plans to help interconnect these optical test beds in the different countries? And on what sort of timescale?
Can I do the presentation first? Yeah, sure. I'll be dealing with quite a few issues.
Okay, so there are 2 ways. Either we start a small discussion, or we start maybe with Vincent's presentation, or someone comes, and then we conclude with the questions. So, we'll be a good summary. Vincent, please.
Welcome everybody. As already noticed, I'm not Howard Davies, I'm Vincent Berghout. Howard is slightly older than I am, and he's got slightly more hair than I got, but hopefully I live up to the same state as he does his presentation. Looking up to my panel here, I hope I can give you some information that will actually tell you that some dreams might come true, and hopefully a bit sooner than we don't have to wait 9 years for that. The presentation is basically on the giant step we're taking. I'll give you some more information in the slides later on. Just a bit about my role. I'm the operations manager at DANTE, and well, usually people internally call me the reader and feeder of the network. If things go wrong, they talk to me, and I'm responsible for all the upgrades and the rollouts. There is a bit of a health warning to this presentation. I'm representing DANTE, and the GÉANT project is run by the NREN consortium. So there are some things that have not yet been decided, so I can't give an answer to all the questions yet. During the presentation, I hope I can answer as many as possible. Let's go to the next slide. GÉANT, well, as you all know, it's French for the big fella. It's actually written with a little stripe on it, so we try to do it as correct as possible. We try to make it an acronym, but in all honesty, none of the acronyms really contained what we were trying to say, because the G in GÉANT could stand for gigabit speeds. We're talking about not aggregated speed, but real speed on links. So that is the target that's there. We would like to continue to provide some guaranteed bandwidth. It's a continuation of the MBS service, and I'll have a slide on that later. The last one is geographical expansion. Well, I could have written down world domination, but that's not what we're intending here. We would like to geographically expand to as many countries as possible. The last one is global connectivity. There was a change in GÉANT from 10155. The global connectivity was sort of considered in 10155. For GÉANT, we've already put all the hooks in place to implement global connectivity. So we're hoping to be one step ahead. Usually I would have called it intercontinental connectivity, but again, that doesn't start with a G. The next slide. Let me tell you just a bit where we are now. 10155 is the current network. It's basically based on two projects. It's the Quantum project and the QNet project. Both of those have finished by now. We decided to continue with the name 10155 as long as we don't have gigabit speeds in there. So we're going to change the name as soon as the first gigabit connection get in. If we have a quick look at the network, we've got a 622 megabit ring. Well, we can call it high speed, but if we listen to all the other speakers, high speed is a relative measure. The other thing is to the ring, to build in some resilience. We've got a lot of countries that are dually connected, and that was one of the design objectives we had with 10155, and I think we've done quite well with that. With 10155 we've already got a number of interconnects. We've got SciNet, the Japanese. We're connected to Canary, CANet, and although not all of the people are connected, some of them have direct connections to ESNet and Adeline. We provide connectivity to quite a few of the DNAs. So, to summarize where we are now, it's the 10155 service. The basic thing for 10155 is the production IP service. It's the core business, and it's the thing that we must do okay, and we're doing this very well at this moment. At least that's what I think. The network started with 16 NLNs, and during the last 3 years we are now up to 20 NLNs. There's one strange, well not strange, a bit different, because we've got one regional network, that's Norbert, and it consists of 5 countries. So there are in total 25 countries connected to 10155. One of the strong points of 10155 is that we had a requirement to build guaranteed quality of service. Well, the only way of building that at that particular moment was ATM. We're running it as an operational service that has been quite successful. It is APN-based. Most of the projects that are connected are using CBR circuits, and they vary between 2 and 45 megabits. It also provides VPN capabilities, and quite a few of the projects that have used it are running their tests on it. So if I'm looking at TS-DANTE and TNC2001, those guys have really used this facility of the network. All right. Well, let's get back. We started with the project 18 months ago. 12 months ago, we really started in anger on the tendering process. At that particular time, we put the targets down. The prime target was to have gigabit speed. The initial start had to be at least at 2.5 gigabits in 8 locations. That was the minimum requirement that was put down for us. In the 4 years of the project, the target is that we have to get at least to tens, but preferably to hundreds of gigabits of capacity. One requirement from 10155 actually stated, remained there, that is the guaranteed service. We should provide improved resilience, and we do need to deliver end-to-end quality of service. There are, for people who want to provide quality, there are 2 groups. The first group is just throwing them without a problem. The other group is that to build some kind of controllable service. I think that GÉANT is so diverse that we need to support both. The next one is the geographical coverage. We're going to connect more countries. I've got another slide on that one later. It's all the European countries and a number of the associate states. The next one is also, we sort of keep it different. That's the European distributed access. The distributed access, the emphasis here is on distributed. We would like to connect to other regions, but we do not want to force them to a particular point. So the design of the network should facilitate which point is most convenient for those people to connect. Let me tell you a little bit about the organization, about GÉANT. GÉANT, it's a consortium of, most of them are European national research networks. It's a long-standing consortium. It has gone through quite a bit of evolution. Most of the evolution has been expansion, so more people are joining the consortium. It's an open-ended consortium, so although GÉANT is the main project, the consortium is not limited to this particular project. For instance, people have been talking about the UNIDIS project. These are projects that should be easily connected to the GÉANT network. So it's an open-ended consortium. There's an NRM policy group or a management group. They decide mainly on pricing and on policy. That sort of leaves the area for what is DANTE's role in that. Well, the NRM policy group, the way they organize it is they can vote with weighted votes. Well, DANTE is we're set up to be an impartial party in there, so we don't have a vote in the consortium as such, but we are the coordinating partner. This is where the plug comes in. DANTE, we're a relatively small company in Cambridge with 17 people. We also have a stand here, so if you want to know more information about DANTE, the project 10155, GÉANT, it's just around the corner. We're here in the dungeons, or maybe I should say in the basement. So please, it's just around the corner, pick up some information. Well, besides that we're the coordinating partner in the project, we also got another role. So part of our role is that we've got delegated responsibility from this consortium to develop the service, to innovate services, and also to implement and operate the network as such. GÉANT, as most of you know, it's a VC-funded project. It's a 4-year project. We've got 25 NRNs. It's the 24 plus 1, so there are quite a few new ones. People always talk about these NRNs, but please be aware that there are organizations behind that. So the total connectivity, if you look at the number of institutions, is probably somewhere between 3,000 and 4,000. There's one thing that people also should know is that the project effective date is the 1st of November. So the funding and the way it's been organized, although the network is still called 10155, the project has already started. So the 4-year time frame is already, the clock is ticking on the project. There's 18 million euro committed by the European Commission, how you want to say it. And within the project, we've also put the hooks in for European distributed access. That is again the intercontinental connectivity. At this moment, we're considering the US, Asia, Pacific, South America, but it's not limited to any of those regions. One particular thing is that there is, I'll have the question later on, so I better answer it now. The provision is made in the project to facilitate those international connections. However, there is no money as yet being allocated for the connections as such. So this is still a decision that has to be taken. Well, to go over the countries that are going to be connected. Croatia, well, they're going to be connected. They are actually already connected. They got a connection to a 34 megabit connection into Vienna. I'll quickly go over the other ones. The Baltic states are members of the consortium, so we've got Estonia, Latvia, Lithuania, Slovakia, Bratislava, we're trying to get connectivity to, and we've got Romania and Bulgaria. So hopefully before the end of the year, those people will be connected to the network. GÉANT, a little bit about the service. GÉANT still has to provide the production IP service. It's our bread and butter. That's the one thing above all we have to get right. The next one is that we started with 10155 to operate a native multicast. The native multicast is another service that must continue for the GÉANT. It's running at this moment, but the rate of change, the stability of the technology is not that far that we can call it a fully fledged operational service, but we're definitely trying to move it in that way. Now the next item is a little bit of a health warning, as it's still in a proposal stage. The two groups are working on those, the next two bullet points. It's the TNC2001 and the GÉANT groups. We're doing a lot of good work, but I will not go in any further detail. You've seen enough presentations on those, hopefully already. The first one is the premium IP service for those NRNs that require a quality IP service with a known service level agreement, for instance regarding jitter, transit delay, IP delay variations and things like that. Beside that, there's a requirement for guaranteed capacity. In the early days when DANTE started as a company, there were a lot of network congestion problems where it was a dog-eat-dog situation. With the APM solution, we avoided that we could give people the bandwidth they subscribe to. Well, that's a feature we would definitely like to keep, and we would also like to keep it for all the projects that are out there. The virtual private networks, again, it's a continuation of the managed bandwidth service. So all the projects that are out there that need dedicated capacity, we would still like to provide them with that the new services, IPv6 has been mentioned. The wording in the contract that we signed with the European Commission and also the agreement we had with the NRN was, well, I think it was a bit woolly. That has been changed significantly. The statement was normally that we would implement it if it came available. Well, that has changed now, and we are committed to implement IPv6 during the length of the project, and we're trying to start with this as soon as possible. We also have to provide support for disruptive testing, and that needs to be an alternative to the ATM service. A quick summary of the hurdles we see ahead. We're moving further ahead to the leading edge, or should we say the bleeding edge of technology. During the process, we actually discovered that there are problems out there that we need to resolve. In the process, we already discovered that there were two problems in the optical layer that people could not provide the services they standard for. One was where the 10 gigabit cards did not work. Another problem was that one of the DWDM providers could not supply 2.5 and 10 gigs on the same infrastructure. We've been going this time in much more detail, and we're aware of the problems that are ahead, but we're definitely pushing the boundary down. The second equipment problem that equipment hurdle we see is actually the router providers. The 10 gigs when we started with the process about a year ago, there was one provider. At this moment there is a second provider, but the 10 gigabits are hard to get. Right. The quality of support, there is nothing that has the same stringent services as the ATM delivered. So things are moving ahead, but they are not there yet. The other hurdle we still see is that, well, I think I described it, the dinosaurs in getting the connectivity. There are quite a few monopolies out there, and it's very, very hard to get those people up to speed with what our requirements are. Some of the providers think that STM1 is the top of the range, and trying to get them to 2.5 or 10 gigs will be an extremely difficult task. It has changed in 1998 quite a lot, and the next slide, or the next one after that, shows this in a picture. The other thing that we have to do in the GÉANT project is the delicate process of matching the cost so that there's a high degree of fairness to how the project is funded. Alright, although the project is started, we would like to roll out GÉANT slightly earlier. So, if we look at 10155, the current network, that is going to be operational until the 30th of November. Now we're trying to roll out the GÉANT network before that, so there should be a period of overlap. About the tender process, we received 78 operators who were invited to tender. Of those, 44 responded with a real offer. So some of the offers were discarded. We also noted that quite a lot of people made alliances and put in joint offers. Of those 44 tenders we've received, there are 16 that can actually provide pan-European connectivity to a larger part, just more than just a few countries. Most of those offer include 2.5 gigabits to countries higher than 5 or 6. They're all based on wavelength in principle. To give you an idea of the complexity we have to deal with, the total number of circuits that have been offered were 4,000. Now to make an evaluation and pick the right ones out of that, it's a very long and tedious process. When we're looking at the procurement, we already see that the targets that we've set for GÉANT, they will be met. initially the number of responses we've got for 10 gigabits were very limited. After the rounds of clarifications, it became apparent that a lot of people are willing to offer 10 gigabits in Europe. Now, any one of you have already seen the presentations of Guy and Howard. This is a slide that I've stolen from them, so you've already seen this particular one. I find it a very good slide because it illustrates what is happening. It's the price development in the international bandwidth. It's on a logarithmic scale, so please be aware of that logarithms have a very, well, I would say, good property for us in this case. The information here has been normalized, so we've excluded the extremes. There were people that made mistakes in offers and charged all ridiculously high prices, like 18 million for an E1, and we've also removed people that were mixing up prices for local loops and international connectivity. So this information, we've taken away the extremes. The lowest offer price is the lowest offer price offered by at least 3 companies. So that should give, it's not one, it is an offer that is really there. Now if we look at the numbers, you'll see that the average offer price and the lowest offer price is growing very rapidly apart. My personal interpretation of this is that when we started, at least when these slides started at 1996, we were still in a monopoly position. If you would buy a circuit from party A, from country A to country B, you would get exactly the same price in country A and country B from the providers. Well, in 1997, the first differentiation, a factor of 30. The year after, of 30%, let's be clear about that one. The year after we still saw that, but with 10155 we saw a change, and that's a significant change. You see that the price, the lowest price was 2,000, but the average offer price was 12,500, which is a factor of 6. Now, for the GÉANT we are actually seeing something that is quite remarkable. The lowest offer price we see is 36, while the people on average are offering the same amount of connectivity for a price of 5,000. Now, this explains a bit on the amount of work we have to do, because we have to get all the offers at that particular level for a level playing field comparison. How do we... Okay, no, let's... I'm going to mention it anyway. 10155. When we rolled out 10155, we saw that the technical variations in the contract were very, very big. And we spent most of the time clarifying with people what the difference was between a VC4 or a VC3, VS3s, E3s, STM1s, and we spent a lot of time on the technical side to make sure that they're all offering the same. Well, with the wavelengths with SDH framing, it all became a lot simpler. And because of all the different pricing structures, getting the financial side, the commercial side on the same side, was much more difficult. The GÉANT technology. One of the questions that has been asked during this year is, should we go for 2.5 or 10 gigabits? Both of these technologies, their wavelengths, and what we're actually getting is simply black and white light. We do not get a color as such. It's simply SDH framing, which is interconnected to the router. The other thing is that we actually don't think it's possible to get access to the optical level at this moment. And also dark fiber, although there are possibilities, if we look at rolling it out at a GÉANT-wide infrastructure, we've got a significant problem. We're talking about 22,000 kilometers. When we were trying to see how complex the problem was. There were something like 78 different fiber providers. Now, if something goes wrong and we have to organize, let's call them the man with the van to repair it, it's going to be a logistical nightmare. So at this moment, we would like to leave the burden with the lambda, with the wavelength provider. That says the aggregated circuit length is 22,000 kilometers. The technologies, although IPv4 will be the main technology used, we will try to implement IPv6 in a native fashion. Also, the MPLS and BitServ will be used to support the quality of service and VPNs. Alright, well, it was called a giant step, stepping to 10 gigabits. What we're planning is that there is a question cost versus capacity that we're now deciding on. The decision has been taken that we should go for 10 gigabits. It will quadruple the capacity and it has quite a few advantages and it adds less than 10% of the cost to it. It says 10 gigabits in 8 countries. That is our ambition. If we look at the offers that are there, we can say that 5 countries are going to be very easy. 6 is probably doable. 7 becomes interesting, but 8 is going to be the challenge for us to make it work. So this is the target we're setting ourselves in the next months to get it connected. Besides the 10 gigabits in this number of countries, we're also trying to push the 2.5 gigs as far across Europe as possible. There's a technical reason to do that. There should be, let's call it the topology indifference, that people should not be bothered where they're connected to the network. There's always been, well, let's call it a requirement, a need for people to determine which circuit should go where in the network. If we provide sufficient backbone capacity, that question becomes significantly less, becomes less significant. It also adds a significant amount of resilience to the network, and it makes the traffic engineering quite a bit simpler. We're going to go to 10 gigabits anyway, so it might be in a year. So starting early, it avoids us upgrading in the next year, which I think is also very important. The upgrades are not an easy thing to do. I think that everybody who's running a network knows the complexity of that. However, there is a technology risk. I would say a lot of people have not used those interfaces in anger yet. So we're taking a bit of a risk there. Alright, that was a bit of new information and I was glad to announce that one. Outstanding issues. We will not be able to deliver a uniform service to all the countries. Privatization has not gone that far. Liberalization has not gone that far that we can get that amount of capacity in all the countries. So we will see that already a larger spectrum of services that are going to be offered. In 10155, the lowest connectivity is 10 megabits. It's delivered in like 34 megabits. The highest access capacity is 622. We'll see that spread will get bigger as the new countries will start joining at lower speeds, while some of the more advanced countries got the ability to go to higher speeds. The bandwidth and VPN capability still needs a lot, still needs development. We're not there yet to roll out the service. There's also a question that the technology might be there. We need to be able to manage it. With the current MBS service, we're able to manage projects on an end-to-end basis, also inter-domain. Well, the key word here is inter-domain, and making that work in a manageable fashion is going to be the big challenge ahead. What we're going to need from you guys, as the Americans would say, is we need a cooperation from the national research networks, but also the people that are operating the mains and the campus networks, if we want to make the VPNs a success. Alright, am I disturbing okay for time? then I got my last slide. Well, I think it says it now, 10 gigabits now, it is available. We're trying hard to build it and deliver it to you as fast as possible. We at least want to keep up with the wavelength network, but I think we're not keeping up here anymore. I think we're really moving ahead of some of the others. So by going to 10 gigabits, a lot of the national research networks have thrown a challenge down for themselves to keep up, which I think is a good thing. GÉANT, it will have a better geographical coverage. We've already seen the countries that I've mentioned in my slide. It is potentially not limited to that. So we're hoping to see more countries connected during the period of the project. We would like to progress on global connectivity. Saying that the provision has been made for EDA actually does not mean that the circuits are going to be there. A lot of the, well, let's call them issues are still out there and need to be solved. But I think that we get a momentum going and people are willing to take it as part of the project. We clearly see that we are challenging the vendors. Well, maybe they are victors. I think I can put a broad pun here that there's one thing worse than a monopoly, and that's a duopoly. If we're looking at what is there on the market, we're dealing with a duopoly. As a summary, I would almost say when we started 1034, if we needed to purchase a card for a router, the manager had to sign a purchase order for a small Norris Mining, a very small car. In 10155, for a router, you probably can buy a Jaguar. I think that if we're going for the vendors, we're talking at least about small Rolls Royces. Getting the technology right and getting it to work is going to be a challenge for both us, the NRMs, and the vendors out there. So we do need the cooperation. Finally, I wanted to say that for the quality of service and the VPN, we need your support to make it work. So there are going to be a lot of questions, and we need a lot of development to make this work. And I'm sort of hoping that you're able to support us in that particular one. And I'd like to thank you there.
Thank you. Are there some questions? Yes, please.
I have one question for Vincent and a story for Dimitrios. Question for Vincent is the one I was asking before. We've heard about 3 optical national testbeds. When do you imagine that we can use GÉANT for interconnecting those? Sometime? Never? Or are there more definite plans? I'm just completely ignorant.
Yeah, it's working. We're talking with those people. We definitely would like to support all the initiatives that are out there. So never is out of the question. I think it's a question of timing to get it incorporated as fast as possible. Mauro and all the people have been talking to DANTE. We would like to cooperate as soon as possible. Initially, it might be just that we provide them with single IP connectivity to access their networks to do the test. We would like to move one step further and participate in the testing itself. Does that answer the question?
Yes, yeah. And the story for Dimitrios was that in my e-newspaper this morning it said how Cisco is today announcing support for IPv6. But take that with a pinch of salt, it was electronic gossip, but and the story basically said all the vendors in the States are coming out with V6 support very soon.
It's not clear. even Cisco a year ago said that they would have delivered production image for that, but that's not the case. And I think it's only one European vendor, which was Telebit, that was hired from, was bought from Ericsson, which has a production router. But when we start testing that in the QTP framework with in QTPv6, we saw that there were major issues connecting the two vendors. So it's not yet clear that when IPv6 will be ready.
Another partial answer to that question is that I think that IPv6 will not be deployed in Europe all of a sudden everywhere. A lot of people is talking about gateways, which looks a nice way to provide the global connectivity. The question is whether or not GÉANT will be IPv6 capable from day one.
I was not mixing it with the GÉANT system.
Okay, I think that production IPv6 images could be in 6 months, 1 year from now, and probably they will start deploying these kind of things in areas and then interconnect these areas to the production network. There is I don't know if someone mentioned it, there is a proposal to the European Commission from Cisco and many NRNs to actually build a separate physical infrastructure on which to build an IPv6 production network for testing. It is a separate physical infrastructure. DANTE is quite involved in that, and the timescale is quite strict. I think it's 2 or 3 years. It's 2 or 3. 2 years. 2 years timescale. 3 years timescale. Okay, but in any case, Cisco is the official contract manager, and as Cisco proposed it, it wants to have results as soon as possible. And the European community is pushing to have IPv6 working just because of the large amount of money that has been poured into acquiring mobile new generation licenses, which need IPv6. So the building blocks are there. Whether or not it will be a reality in 1 year from now, I don't know.
I'd like to ask something to Vincent. Vincent, you said that VPN will be provided. Are there's going to be layer 2 or layer 3 VPNs?
Thanks. Sabine, can I ask a question?
He
was there before.
Yes, I'm sorry, I haven't seen you.
Sorry. Okay, a question for Vincent. He mentioned the European Distributed Access, EDA, and possible funding for that. Does that mean it's possible for an NRN outside the consortium to connect to GÉANT at less than the cost of one of the members of the consortium?
So, 2 questions.
This is a trick question. No, we sort of made it had to be we call it intercontinental connectivity. So the objective is to connect to other regions. And
so you have to be on another continent.
You have to be on another continent.
All right. But my question still applies. I mean, would it be possible for NRNs in other continents to be treated more favourably than members of the consortium?
Could you put
It's on. Is it possible for members of for NRNs in other continents to be treated more favourably than members of the consortium? In other words, to be funded more than the funding that NRN members are getting?
I can't say for the policy committee. They have to decide in the end, but I don't think so. It's European funding, and my understanding of it so far is that it would have to be on a separate track, and that is why it's not part of GÉANT. The funding of the connectivity itself, and how that will work in the future, I can't say.
Vincent, can you please answer Dimitrios' question, and then we will close the session because we're quite late already.
All right. Well, the answer to the question is probably both. An amount of layer 2 is needed as we need to support disruptive testing, and the best solution for that particular problem is to do it on layer 2. For VPNs, the easiest way to get it as far as the institutions to support them is to keep it on layer 3. So I think the answer is going to be both.